Question 14. Here is a question on factoring difference of cubes, and let's try to understand difference of cubes. I hope you remember the formula. Let's write down the formula first, which is a cube minus b cube is equal to a minus b times a square plus ab plus b square. Correct? That's the formula for a cube minus b cube. Here both the problems are a cube minus b cube, so we can use this formula, but is there a good time to give you or share with you what will be a cube plus b cube? If the formula was a cube plus b cube, then what happens? This sign changes. That is all. Otherwise it is same. So it's a good practice to write both the formulas together in the same way. And I would like to change the problem here. I will make it plus here, right? So we'll use both the formulas and then do our question. Correct? Now, okay. So let's divide this page. So this is a cube minus b cube. How? Because 8 can be written as 2 cube. So let me write this as 2 cube x cube, and 27 can be written as 3 cube. Right? Now, so we can now use a cube minus b cube. That means a minus b. What is a for me? A is 2x, like 2x whole cube, right? So it is 2x minus 3 times a square. So 2 square x square. So don't forget to write 2 square. 2 square is 4. 2 square x square plus ab, that means plus multiply 3 and 2x. So when you multiply 3 and 2x, you get 6x plus 3 square, which is 9. Let me write 3 square first, and then I'll write the final line, which is 2x minus 3 times 4x square plus 6x plus 9. So that is how I'm going to factor it, right? So here you saw, to start with, what was a? A is equals to 2x, right? And b was 3 for us, correct? 3 squared. Do you see that? And then we use our formula. Now here 16 is not a perfect cube, nor is 54. I have purposely given you this question and this question on the same page. So what I will do here is I will show you how they're exactly same. So I'll factor 2 out. That is like grouping. Do you understand? At times in test I have seen these kinds of questions. They're tricky. So if I factor 2, then what do I get? I get 8x cubed plus same thing. Do you see that? Now it becomes a perfect cube, as we did here, right? So we factor out 2 and make the question same as what it was. So when you don't directly get a cube root, right, try to see for common factors. That will help you to solve the question. So the whole idea of giving this question here is to bring to your knowledge that sometimes you can use group factoring, right? Group factor out 2. Now I can write this as 2 times. Now this is the cube, right? How? I can write here as 2x whole cube. Do you see? This time I'm writing this as a plus 3 cube. Do you get it? So now it becomes a cube plus b cube. I changed the question to use this formula, right? Now this can be expanded and can be written as, this is a for me, 2x, and b is 3. So I get here 2x plus 3. That is a plus b, right? 2x plus 3 times a square. A square is this square. What is square of 2? 4. And x square, a square. Now when you write plus here, then minus this time. Minus. Multiply these two terms. 3 times 2 is 6. 6x plus 3 square, which is 9. You see, you get your answer. Right? Let me write it neatly, which is equals to 2 times 2x plus 3 times 4x squared minus 6x plus 9. That's our final answer, right? So that is how you are going to do difference of cubes. Now I'll take two more examples, question 15 and 16. And there what have I done is, I've used the same formula, cube, but I've made them cube of cube and square of cube. That means the degree of those binomials are 9 and 6. So that means you can factor and then again factor. Do you see that? Understand that technique with next two questions. It will give you extremely good practice for handling difference of cubes or sum of cubes in your test on factor polynomials. Thank you.